Hey guys, so I've been working on this RimWorld ripoff in Godot for a while, and I really wanted to have a go at 3D. So this is what I've got after playing around for a little while. If you guys want to follow on and see how I did it, here I go. Okay, so I'm going to start a new project for this one. So I'll start a new 3D scene, and I'll just make my main node be the world. And what I'm going to do is add a mesh instance 3D. And so this will actually be the holder for the mesh we're going to make. What we're going to do is this is actually going to be what's called a chunk. And a chunk is like the minimum mesh in Minecraft or in the game that we're going to make as well. So it's not one cube. It's more likely going to be like a huge block of like 32 by 32 cubes that we're going to render at one time. And the reason we do that is because of the way that the video cards work. You don't want to send them like billions and billions of individual tiny meshes. It's better to give them one big one. And there's limits, of course, but we're just going to sort of set a balance between having one good big mesh that the video card can eat at a time. But also if I've got to like change one part of a mesh, I don't want to rebuild the whole mesh too much if I don't have to. So that's the sort of balance we're doing. So let's make a script for this one. And yeah, we'll call it chunk. And the first thing I'm going to do, because I'm going to be iterating a lot at the start, I'm going to make this into a tool so we can see what's happening in the editor without having to start the game every time. So what I'm going to do is go export var update mesh, and that will be a bool. And after I save and just click here, you can see I've got a little button over here now. And what we'll do is just make it so if update mesh is true, then we'll run, let's just call it gen cube for now. And then make sure we set update mesh back to false. Otherwise it'll keep running again and again and again. Func gen cube. And let's just go print hi. Let's just make sure everything's working. So now when I go click here, it'll say hi. If this isn't working, go up to project, reload it again. That often fixes it when you're playing with the tool. All right, so let's work out how to actually build a mesh. So the basic things, I'm going to copy and paste them in here so you can see. And so we've got our array mesh, which is going to temporarily hold all our stuff. And we've got our list of vertices. And what vertices are, if we have a look, if we're going to build our cube like this, 1, 2, 3, 4, just build our cube. The vertices are these points here. And as you can probably imagine, those are the most important points. Not the only important points, but that's the basis that we build everything on. So the list of vertices, the indices, what that does is that tracks, we're going to have our first 1, 2, 3, 4 vertices, and then we have to build 2 triangles. And what the indices are is just tracking. We're going to go from a 0 to 1 to 2, and then back to 3, and it tells it what order to draw this triangle. So it's got a list of the vertices, and the indices tell it which indice of those vertices to draw the triangle. So 0, 1, 2, and then we'll go like 0, 2, 3 will be the second triangle, and that'll give us the top face. And then finally we've got UVs, which tells it how to take a picture and stretch it over this. And so that's the start. And in the end, which I'll do first, is this, which sort of takes that array, which sort of takes all that stuff, puts it into a new array, chucks it into the Godot mesh building stuff, and just, so mesh is where we're taking our A mesh, our array mesh, and copying over this mesh with it. And so all these, we can just declare them in here, but I'm going to declare them globally. And that'll mean I can sort of reuse them again and again later, which we're going to do. We're going to be redoing this mesh again and again and again. Whenever you tick a little block, it's going to change. All right. Now this middle part here, this is where we're going to actually define all this stuff and draw these vertices. So the first one, now first we've got to work out what is our sort of space, our 3D space. And you can see here what we've got. We've got the red X with positive going this way, Z going to the left there, and Y going up positive. So let's draw this here. We've got our positive X going this way, our positive Z, and our positive Y. We're going to do our top face first. So all the y's are going to be the same. And what we're doing is we're building this around that center point. So it's actually going to be y is going to be 0.5. So 0.5. And x is going to be, we're going to start this one. So that's to the left. So it's minus 0.5 for the x. So we're here, we're to the minus of z. So for z, it's minus 0.5 as well. So x, y, z is going to be minus 0.5, 0.5, 0.5. And so we just go vertices dot append, and our first vector 3, it's going to be minus 0.5, 0.5, minus 0.5. And so we're going to need 4 of these. And so all the y's are going to be the same. They're all going to be positive. But this second one, and we're going to go clockwise, is going to be same for z, but it's going to be positive x. So we just go and change our x to a positive. And the next one is going to be the same for x, but it's going to be a positive z. So we're going to have x the same and a positive z. And then the final one, we're going to still be a positive z, but we're going back to the minus on the x. And so that's it. That's our 4 vertices at the start. I went through that pretty quick, but if you sit there and work it out one by one, that's what it'll be. We've got a lot to do. So let's keep going. So the next thing we need is the indices, the order in which we draw our triangles. And so this works the same way, indices.append. And so we're just doing the first one is 0. And then 1, and then 2. So that's our first triangle. 0, 1, 2. And the next one's going to be 0, 2, 3. 2, 3. And the final thing is the UVs. And so same thing, UVs.append. And we need 4 of these. And these are vector 2s. And so for now, we're just going to go 0, 0. So that's like the top left of the image. We're going to go 1, 0. We're going to go 1, 1. And then finally 0, 1. I think that's right. Let's check that. I'll have to check that one to be sure. And that's it. So before we do anything else, I need an actual material. So we've got some color to put on this. Well, we can try it actually. So let's go back to the 3D world. Let's press update. And you can see I've actually got my face. And we're going to perspective here. And if you put it into wireframe mode, you can see my 2 triangles. So that's my 0, 1, 2 and my 0, 2, 3. So now let's put a mesh on here. You can see you can't see it from the bottom. You can only see it from the top. If you wanted to see it from the bottom, you have to do the triangles the opposite direction. So for the first quick test, I've just made this quick image, which is a grid. So let's go and create a new resource. We're going to make a material, standard material 3D. And let's just make this grid matte. And so what a material is that tells it how to draw the texture. That's all your shaders and nonsense like that. So let's get our material, set the albedo to be our, to be our texture. Then I can drag my grid material onto here and you can see it's come out nicely. Good. So that means my UVs worked as well. And to give you an idea how this works, what the UV is doing when I've got that 0, 0, 1, 0, what it is XY coordinates. So 0, 0 is telling it how to stretch this. So it's XY 0, 0, and this would be XY 1, 1. And so we're telling it how to stretch. And I'll show you if I changed one of these ones to 0.5, what that does is you can see it sort of stretched halfway across. So if I wanted to make my texture be twice as big, I set all my ones to 0.5. And you can see now we're basically effectively using 0.5, 1/4. So I'm not going to go too much into UVs in this one, but that's sort of what they do. All right, now before we go and make the other 5 sides, I'm going to change that a little bit. I've made this cube test, and what it is it's a map where I've got the top, the bottom, north, east, south, west. So as I'm drawing this, I'll make sure all the UVs are set correctly, and you can see I've got little grass things on there for testing as well, and just numbers on the ones I've not set up properly. So let's change that now. Instead of using the grid, and you can see what I want to do is just have that T. And so the way I would do that is make all these 0.25. So that's my top. And the trick is to slide these across. And the way we're going to do that, so this 0.25 is always going to be the same. And we're going to make a new one called texture divisor. And so for this one, that's going to be 0.25. And I'm actually just going to make a little function to do this for me. So func, let's call it add UVs. And we're going to put the X and the Y coordinates of my map in there. So the X and the Y coordinates for this one is 0, 0. And so we'll just cut and paste this one. And so the way it's going to work, this first one is going to be the texture divisor multiplied by X. And the second one's going to be the texture divisor multiplied by Y. The second one is going to be the same. But this one's going to be the texture divisor multiplied by Y, by X, sorry, plus the texture divisor again. And you can, this one's got the 2 numbers. This is, you can sort of guess what's going to happen next. This one's going to have the texture divisor added after the Y. And then this final one. So now instead of this, we'll go add UVs. And it should be 0, 0 for the XY. And let's quickly make sure that works and didn't break anything. There we go. We got a little bit stretched, look at that. Yep, and that's just because I forgot to add the text div on this last one. All right. So now, the good thing is I don't have to think about this too much anymore, because that should just handle it. As long as we're just doing simple squares, it'll work. All right, so this effectively draws one face. Before we move on, let's just make a function to do this indices for me again as well. Because what's going to happen, we've got this part here, which draws our, top. And we'll just copy and paste this. And we'll start off by doing the east. And I don't want to have to do this again. And it's going to effectively be the same because we're going to draw the same triangles. But when I say 0, it's going to go back to this first one. So what we're going to do is add one more little variable, which is our face count, which is going to track how many faces we've made. So at the very start, we'll just go face count equals 0. And these will just be, face count, plus 0. So plus 4 times 0. And I'll keep this one the same for now. And so you can see this will be exactly the same. And then after we do this face, we just go face count plus equals 1. And so that'll handle this. All right, now let's work out our east wall, which is the tricky part. So now we're going to do this guy here. And so we're going to, once again, we're going to go the same order, sort of left to right, down and across. So it's all going to be on the right side. So X is always going to be positive. So let's go and make all our X's positive. And then we're starting here. So it's going to be Z positive and also Y positive. So Y positive, Z positive. And as we're moving to here, it's Z negative, Y positive. So Z negative, still Y positive. And we're going to Y negative, Z negative. So Y negative, Z negative. And then the final one will be Z positive, Y negative. So Z positive, Y negative. And the one last thing is just picking our letter here. So it's east, so it's 0, 1, 2, 3 for my UV position. And let's see if that worked. And we should get a lovely square here. Sorry, these should all be 0 times 4 plus 0. Yeah, so that was obviously making it very wrong. So let's try that again. And yeah, that fixed it. So now I've got my top, I've got my east. And so before we go and do the final ones, let's just quickly dump this into a method. So let's just go func, add triangles. And we just take that and chuck it in here. Great, and now you can see why I made all these be top level, so that I don't have to like pass them into arrays and go back again. Makes it much simpler. All right, let's make sure we didn't break that. That's it. All right, I'm going to quickly go through and add the rest of these faces. All right. So that's working. Let me just show you here what we've got. So we've got the top, the east, the south, the west, the north, and the bottom. And if we ever wanted to take away one face, say we didn't want the north face anymore, we can just basically not do this part and then nothing else will break. So there's the north one, it's not there. And which is exactly what you do if you had another one here. You wouldn't want to draw that one in the middle because that would be a waste. And that's the sort of thing we're going to do next. So we can draw one. And so the next trick is to build a whole chunk of them. So that's given us that very basic functionality to build a single cube and given us our little first step we can work from. Okay, so now that we can make one cube, let's make an entire chunk. So I think what I'll do is let's make our size, let's make that an int and let's make it 16. And so my chunk will be a cube. It could be different dimensions, but let's just do it one, keep it like that. And down here, we're going to have a little variable here to hold our blocks. And that's going to be, it's actually going to be a 3-dimensional array. And so the first thing I need to do is initialize that array. So let's just go func init block array, and we'll go blocks.resize and resize it to that chunk size. And then I'll just go for x in range chunk size. We'll go blocks number x equals a new array. And then we'll go for y in range chunk size, blocks number x, and we'll append an array to that. And then for z in range chunk size, we'll go blocks number x, number y, and we'll just append a 0 to it. Sorry, I've called it block, not blocks. And this is just, I'm not a huge fan of the Python way of doing this 3-dimensional arrays. But what we've done is we've basically made this into a 3-dimensional array, and every single one has got a 0 in here. And what that 0 is going to represent, in fact, let's just do this now. I'm going to move this to somewhere else, but enum block type. And so we've got air, and let's just have dirt, so we'll have 2. And so this is actually going to be block type. You know what, let's make them dirt by default. And so I want to keep the thing in this array to be actually really simple, because we're going to have absolutely, hundreds of thousands, if not millions of these. We have to keep them really simple. So these are just little integers. All right, so that should just create one giant cube of dirt. And now we need to make sure we're actually making a cube for every one of those. So let's just go func gen cube mesh and the pos, which will be a vector 3. And so basically this part here, we'll cut that out. And let's generate my whole chunk here. And so here we can go basically for X in range chunk size, and here's where we'll go through the entire thing and actually generate those cubes. And so if blocks number X, Y, Z equals block type dot air, there's nothing to make. We'll do nothing, or else we'll go gen cube mesh, and the position will be, vector 3 will be X, Y, Z. So then that should make all my cubes and then pass the info back to here. So at the start now we just have to go, not gen cube, generate our chunk. And we'll initialize our block array in there as well. For now, let's have a quick check. I'm not sure if that's everything. Oh, I've got to set this to 16. Oh, what an idiot I am. I'm making the exact same cube so many times. So what we need to do is take our position we're passing through here. So gen cube mesh. And we're just going to add that position to there. So to offset each of these faces. There we go. Let's give that a crack. And there we go. So you can see now we've got our 16 by 16 by 16 cubes. And now you can see it actually still runs really well, but we're going to start running into problems because you can see we're actually building that south face so many times. So we're making all these faces which are never being displayed. So what we need to do now is basically check so we're not going to do that anymore. And there's a couple of ways to do it. One is to only draw when there's air on one side and dirt on the other. And the other would be to check if there's a dirt on the other side to not build one there. But I think let's just check for where we've got air. And so first let's make a little helper. So we'll make a little helper here, which just goes func block is air, and we'll feed that a position. And the first thing we'll do is we'll go if pos.x is a less than 0. It's an impossible one, so it must be air. Or pos.y is less than 0, or pos.z is less than 0. And we'll get all these sort of impossible cases. And we'll return true. We'll just call that air. And if pos.x is greater than or equal to chunk size, X, Y, Z, and then we'll go else if aleph blocks number X, Y, Z actually is return true, or else we'll return false. Oops. pos.x, pos.y, pos.z. Okay, so now what we do is for each of these faces, we just go if block is air pos plus vector 3, and so we're checking, so this is the top, so we're checking if it's the one above it. So for X we do nothing, for Y we go +1, for Z we do nothing. And if it is air, then we'll draw it. And let's give that a quick try. And so now when I look down, we should only have, there we go. We've only got that one top one, and the rest are not drawn. And you can see for the others, it's still like that. So we have just saved so many faces. All right, let's quickly do this. All right, so now we should only build those faces around the very, should only do these tops, this sides, so the whole inside should be empty. And let's actually have a look at the wireframe. And you can see it's full of nonsense right now. Let's draw it, and suddenly you can see it's so empty inside. So suddenly, where we were drawing thousands and thousands and thousands of triangles, we're building hardly any. All right, I'm going to leave the optimization done for now. The other big thing we can do is called greedy meshing. Since this is actually just one big square, what we could actually do, instead of making all these little squares, we could just do two giant triangles. But that's a little bit more of an in-depth algorithm writing that, especially if it's going to be something more jagged rather than just a big square as it is now. So I'm not going to do that yet, but that's a great thing that we will probably have to come back and do later. We'd use something called the greedy meshing algorithm to do that. But for now, let's just apply some randomness to this and see how it looks. So let's go back to where we initialize our array, and we just need to decide here whether it's going to be dirt or air. And so what we'll do is we'll go var rng equals, what was that called? Random number generator dot new. And I can just go if rng range 0 to 10 is less than 5, we'll make it dirt, or else we'll make it air. And this is definitely not how we're going to do it, but I just want to do a quick test. And yeah, that worked really well. You can see now we can arbitrarily draw any of these cubes that we like. All right, now a more realistic 3D would be to do some Perlin noise. And so let's go var noise equals fast noise light.new. Let's make the seed always the same. Noise.noise type equals fast noise. Let's make it cellular just by default. And then we just go if noise.get noise 3D x, y, z is greater than, I think, minus 0.5 is a good start. Let's see how that works. Get noise 3D. And let's actually write this threshold in. All right, so let's make that threshold minus 0.5. And you can see I've just got one little bit sticking out. Let's make it minus 0.6. And you can see we've got this nice 3D noise now. Yeah, so we'll definitely be doing the noise differently later. But this is good for now. And you can see we even do some stuff like, let's make this chunk bigger, and you can see I've got these beautiful big chunks now. And like I was saying before, the reason we go a smaller chunk is because, say I want to dig this block right here in game, it has to redraw this entire thing, and so you wouldn't necessarily want to doing that much. So something like 16 is good if they're being changed a lot. If they're never being changed, we can actually go way bigger, draw them once at the start, and let the graphics card handle it all at once. All right, so that's a decent start. I think I'll leave this here for now and think about how I'm actually going to make this terrain, and then actually start doing the world and having multiple chunks and work out how we're going to address the chunks. But thanks for hanging out, guys. I'll see you later. Hopefully this isn't too much of a departure from what everyone else is making. And if you can, throw us a few dollars in the Patreon, because it doesn't look like I'm going to be finishing and selling this game anytime soon. I'd appreciate any help you guys could give me. All right, have a good one.